Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe.
Level 62. Determine the moments of inertia with respect to the centroidal axis IGX and IGY, shown with respect to centroidal axis respectively parallel and perpendicular to side AB. So we will call the centroidal moments of inertia respectively as IGX and IGY, although you can call it I barred X and I barred Y. So for our solution, let's divide the area into the manner shown. So we have area 1. This is the other uh, division. So we have three different rectangular areas. The area of the first is 1.3 times 1, so 1.3. This is zero point 0.5 times 3.8. This is the centroid. So the area here is 1.9. This is 3.6 times zero point 0.5, so the area is 1.8. Then for the horizontal distance of the centroid from the left, 0.65, and from the vertical, 4.8, where 4.8 is zero point 0.5 plus 3.8, 4.3 plus half of 1, zero point 0.5, so 4.3 plus zero point 0.5, 4.8. For this area 2, the centroid, so since this is 0.25, I will not show it anymore. We'll just show the vertical distance of the centroid of that area to 0 0.5 plus half of 3.8, 1.9, 1.9 plus zero point 0.5, so 2.4. Then for this centroid here, its distance from the bottom is half of 0.5. I will not show it, but its distance from the left, from the left edge, which is the vertical, let's call this the y-axis also, is half of 3.6, so 1.8. So area is equal to 1.3 plus 1.9 plus 1.8, so area equals 5 square inches. Then apply Varignon's theorem to solve for xg. So let's locate the g, centroid of the entire section. Call that xg, the vertical distance from the bottom. Let's imagine this the x-axis is yg. So 5 times xg equals 1.3 times 0.65 plus 1.9 times 0.25 plus 1.8 times 1.8. So xg is equal to 0.912 inch. Then for yg, 5 times yg equals 1.3 times 4.8 plus 1.8 times 2.4 plus 1.9 times 0.25. So yg is equal to 2.25 inch or inches. Then we now apply transfer formula for moments of inertia. IGX equals for area 1, 1.3 times 1 cube over 12 plus area 1.3 distance with respect to the z-axis is quantity 4.8 minus yg, which is 2.25 quantity square. For area 2 plus base 0.5, height 3.8, cube over 12 plus 1.9 area times distance square. Distance square is 2.4 minus yg, 2.25 square. Then plus for area 3, moment of inertia is with respect to the centroidal axis is 3.6 times zero point 0.5 cube over 12 plus area 1.8 distance yg minus 0.25 quantity square. This is the centroid, so this distance is yg minus this distance 0.25 quantity squares. Solving for igx individually, first we have 8.5616 plus this one is 2.3291 and the last one is 7.2375. So igx is equal to 18.13 square inches to the fourth. Likewise for IGY, so we just interchange the quantity that is cube here, and the distance would be delta x. So IGY equals 1.3 cube times 1 over 12 plus area 1.3 times distance xg minus 0.65 quantity square. Xg is 0.912 minus 0.65. So the horizontal distance between that axis and this axis is 0.912 minus 0.65. Then plus 0.5 cubed times 3.8 over 12 plus 1.9 times xg 0.912 minus 0.5 quantity square, 0.25 quantity square. This is 0.25 plus uh, plus 3.6 cube times zero point 0.5 over 12 plus 1.8 times quantity 1.8 minus xg 0.912 quantity square. So computing IGY equals, the first is 0.27232, the second is 0.87225, the third is 3.3634. So moment of inertia with respect to the centroidal axis perpendicular to AB is 4.508 inches to the fourth. Level 63, determine the moments of inertia, IGX and IGY of the area shown. So with respect to the centroid. So for our solution, let's tabulate the solution this time. So we have element, that's the centroid, which lies on the y-axis also by symmetry. So element, we have area in mm square, the x of the individual, barred x of the individual element, barred y in mm, then area barred x in mm cube, area barred y in mm cube, to locate the centroid. So for the big semicircle, this big semicircle here, the area is pi 80 square over 2, so that's 3200 pi. The x is 0 here, so it's 0. The y is 4r, because this is the x-axis. 4 times 80 divided by 3 pi, so you use your calculator there, 33.953. Then 3200 pi times x, 0, so 0. Then 3200 pi times 33.953, it's this value here in mm cube. Next is small semicircle small. Since it is to be removed, so its area is negative pi 60 square over 2, so negative 1800 pi. Its x is 0 by symmetry. Its y is 4 times 60 divided by 3 pi, 4r over 3 pi. So 4 times 60 over 3 pi is 25.465. Area x is 0. Area y negative 1800 pi times 25.465, negative 144,001.18. Then for this rectangle here, it's below the x-axis. So area is 160. This is 160, 2 times 80. So 160 times 20 is 3200. X is here, so 0. Y is below the x-axis, so negative 10, half of 20, so negative 10. Area x 0. Area y is negative 32,000. So summation of areas in decimal 7598.23 mm square. Summation of area x 0, summation of area y is equal to that value 165,331.61. Therefore, xg is 0, yg is xg, by the way, is summation of area x, 0 divided by summation of area. Yg is summation of area y divided by summation of area, so yg is 21.759 mm. Then for moment of inertia, igx, for the semicircles, it is 0.10976 radius to the fourth. Then we transfer it So plus area of big semicircle times distance square, distance between its centroidal x-axis and the centroidal axis of the entire area. So since yg is 21.759, y of the big semicircle is 33.953, so 33.953 minus 21.759 quantity square. So IGX is 0.10976 of 80 to the fourth plus area times distance 33.953 minus 21.759 square. For the next semicircle, so minus uh, 0.1097660 to the fourth plus area 1800 by distance 25.465 minus 21.759 quantity square. For the rectangle plus 160 times 20 cube 160 times 20 cube over 12 plus area 3200 distance 21.759 minus negative 10 so plus 10 21.759 plus 10 quantity square. Because this is the centroidal axis, distance from the x-axis is 21.759. The centroid of the rectangle is 10 mm below, so the total distance is that. Computing IGX equals the first in times 10 to the 6 is 5.9906, second is negative 1.5002, the third is 3.3343, then quantity times 10 to the 6. Combining IGX is equal to 7.825 times 10 to the 6 mm to the fourth. Or we use IX equals IGX plus area YG square. So where IX is moment of inertia of the figures, different figures with respect to the horizontal, which is in this case x-axis. So for the big semicircle, it is pi over 8 reduced to the fourth. So Ix is pi 80 to the fourth over 8 minus pi 60 to the fourth over 8, then plus 160 20 cube over 3, because we have rectangle with respect to the base with respect to the x-axis. So Ix is equal to 11.4222 times 10 to the 6 mm to the fourth, then equate it to IGX plus area 7598.23 YG 21.759 square. So the result would be still 7.825 times 10 to the 6 mm to the fourth. Then for IGY, so the y-axis happens to be the centroidal axis also of the three areas. So it is just two semicircles with respect to the y-axis. So it is pi over 8 reduced to the fourth. So IGY equals for the big semicircle pi 80 to the fourth over 8. For the small semicircle pi 60 to the fourth over 8. For the rectangle 20 160 cube over 12, or 160 cube times 20 over 12 with respect to the centroidal y-axis for this rectangle. So combining IGY equals 17.82 times 10 to the 6 mm to the fourth. Level 64, develop a formula for the moment of inertia of the regular hexagonal area of side A about its central x and y axis. So here is the given figure and the orientation of the regular hexagon with side A. So remember that this hexagon is composed of 6 identical equilateral triangles. This is also side A, this is also side A. So for our solution, let's have isolate this one in preparation for our solution. So this angle is 30 degrees because the interior angles of each is 120 degrees. So divide by 2, 60 degrees. Then vertical and horizontal 90 minus 60. So this is 30 degrees. And the side is A. So a sine of 30, so therefore this is half of a, zero point 0.5 of a. Then a cosine of 30, this is square root of 3 over 2 of a, to be exact. This is the location of the centroid. So from the x-axis, a over 2, this is a over 2 plus 2/3 of 0.5a. Distance from this vertex to the centroid vertically is 2/3 of 0.5a. Or the other way is, this is a, then minus this distance 1/3 of 0.5a. So that's 5 over 6 of a. So again, 5 over 6 over a is a over 2 plus 2/3 of zero point 0.5 of a. So 5, 6a. The other way is a minus 1/3 of 0.5a. So a minus 1/3 of 1/2. So a minus 1/6 of a. So 5 over 6 of a. Then this distance is 2/3 of square root of 3 over 2a. So that would be square root of 3 over 3 of a. So ix equals igx equals, imagine we have a big rectangle. The dimension would be 2a here. This is 2a horizontally. Sorry, 2 times square root of 3 over 2 times a times 2. So square root of 3a. Again, square root of 3 over 2a times 2. This base here of the imaginary rectangle, this rectangle here, is square root of 3a. The height is a plus a. So a plus a is 2a. 2a cube over 12. So that's the big rectangle. Then we will subtract the moment of inertia of this triangle with respect to the x-axis, then multiply it by 4. So let's transfer it here. So minus 4 times uh, minus 4 times square root of 3 over 2a, 0.5a cube over 36 plus area 1/2 of square root of 3a over 2 times 0.5a, distance is 5/6a quantity square. So it is now transferred. Then let's compute individually. Ix is, for the first term, is 2 square root of 3 over 3a to the fourth. 4 minus 4 times this term here is square root of 3 over 144a to the fourth, and minus 4 times this term or quantity, 25 square root of 3 over 72a to the fourth. Combining, ix equals igx equals 5 square root of 3 over 16a to the fourth. For igy, let's refer to this solution. Let's interchange the quantity that is cubed. So iy equals igy equals quantity square root of 3a cubed times 2a over 12 minus 4 times square root of 3 over 2a cubed times 0.5a over 36 plus 1/2 square root of 3 over 2a times 0.5a, then distance square root of 3 over 3a to the fourth. So this is the distance to the fourth, or square rather. So computing each, the first term is equal to square root of 3a to the fourth over 2, then minus 4 times this term, square root of 3 over 48a to the fourth, then minus 4 times this whole quantity here, square root of 3 over 6a to the fourth. Combining, it is equal to 5 square root of 3 over 16a to the fourth. The other way of computing Iy is moment of inertia of this rectangle here. This rectangle, inner rectangle, the dimension is square root of 3 over square root of 3a, and the height is a because this is the side a. So square root of 3a quantity cube times a over 12. Then plus, there are 4 identical triangles. Moment of inertia with respect to the base is this base here, square root of 3 over 2a quantity cube times height 0.5a over, then over 12 times 4. So igy equals square root of 3a cube times a over 12 minus 4 times square root of 3 over 2 cube times 0.5a or a over 2 over 12. So this is times 4. So plus moment of inertia of this triangle with respect to the y-axis or with respect to this y-axis here. Formula is base cube. So square root of 3 over 2a square root of 3 over 2a quantity cube times height 0.5a a over 2 then over 12, then multiply it by 4 because there are 4 identical triangles. Combining, the first term is equal to square root of 3 over 4a to the fourth, while the second term is square root of 3 over 16a to the fourth. So combining, the answer would still be the same. 5 square root of 3 over 16a to the fourth. Level 65, determine the moments of inertia ICX and ICY through the centroid of the cross-section of the beam shown. So the area is symmetric with respect to the y-axis, so there's no need to solve for barred x, it is 0. We only compute for barred y. So the area for our solution, the area here is 25 times 100, 2,500, and this is also 2,500, 2,500. Then this one is 50 plus 25, 75, plus 75, 150, times 2, 300, plus 25. The total base of this middle rectangular section is 325 mm and its height or thickness is 25 mm. So the area is 325 times 25, that's 8125 mm square. Not shown, but you can compute it, 325 times 25. So the area is 3 times 2,500 plus 8,125. So area equals 15625 mm square. Applying Varignon's theorem, 1562 or moments of area, first moment of area, 15625 times barred y equals 2 times 2,500, then quantity 75, the distance of the centroid of these two from the x-axis is 75. Half of 100 is 50. 50 from here to here plus 25, so 75 mm. Then plus 2,500, the distance of the centroid of this rectangle from the x-axis is only half of 100, so 50, but it is negative because it is below the x-axis. So negative 50 plus 2,500 times negative 50. Then for this rectangle plus 8125 times distance from the x-axis is half of 25, so 12.5. So plus 8125 times 12.5. Solving for barred y is equal to 22.5 mm. Again, barred x is just 0. Then by transfer formula for moment of inertia, take note that these two are identical. So ICX is 2 times 25 times 100 cube over 12 plus 2,500 times quantity 75 minus barred y 22.5 quantity square. So the distance between this centroidal axis and this axis here is 75 because this is 75 minus barred y. So that's 75 minus barred y. 75 minus 22.5. So quantity square. Then plus for this rectangle here, 25 times 100 cube over 12. the distance of this centroid is barred y 22.5 minus negative 50, or barred y plus 50, because this is 50. So plus 25 times 100 cube over 12 plus 2500 times quantity 22.5 plus 50, barred y plus 50 quantity square. So this is the centroid. So this distance is 22.5 plus 50. Then for this rectangle here, plus 325 times 25 cube over 12. Then area 8125, distance is barred y minus 12.5 quantity square. So barred y, this is the centroid of this rectangle. So this distance is barred y minus 12.5, half of 25 quantity square, or this one. So in scientific notation, 10 to the 6, the value of the first term is 17.948 times 10 to the 6, second 15.225, third is 1.236 times 10 to the 6. So ICX is equal to IGX 34.41 times 10 to the 6 mm to the fourth. For IGY, these two need not to be transferred. Y-axis is also the centroidal axis, centroidal y-axis of these two rectangles. So we just transfer these two about this axis here. So ICY equals IGY equals 2 times 25 cube 100 over 12 plus 2500 times 100 square. 100, the distance of the centroid of this rectangle from the y-axis is half of 25, 12.5 plus 75, 87.5 plus another half of 25. So that's why it's 100 square. Then plus for this rectangle with respect to the centroidal y-axis, 25 cube 100 over 12 with respect to the centroid. Then for this rectangle with respect to the y-axis, or the centroidal axis, it is 325 cube times 25 over 12. 325 cube b cube, height is 25, then over 12. Combining, ICY equals IGY equals 1 to 1.9 times 10 to the 6 mm to the fourth.